Hello students, welcome to EPG Pathshala. My name is Yatrik Patel and I am working as scientist at Information and Library Network Center. In today's paper, that is Digital Library, we are going to learn about technical infrastructure of digital library. Now, if you can recall, in earlier module, we have cleared the concept of digital library, and we know that objective of digital library is to provide information services to the users. Now, the information services which are required also need to establish several technical infrastructure or components to the library. Now, this technical infrastructure requirement is the server side components, the client side components, the network infrastructure, the software which is required on server as well as client side, as well as the hardware which is required at server as well as client side. Moreover, nowadays the cloud computing also plays the major role in establishing the digital library. Now, when we talk about digital library infrastructure, there are various things for which user is not much concerned. User wants all of his services on a single desktop or on a single platform, and or one can say digital library portal. But in the back end of the system, there is a huge, or there are number of components which plays a greater role in harmony. As I told earlier, these components are servers, network, the equipments which are required for network, that is routers and cabling and all, the software which are required to run the server, the client side component. Now, client side component may be anything. It may be a desktop PC, it may be a tablet, it may be a mobile device, etc. As well as several data which will be indexed, stored and disseminated can be there on the cloud. So, cloud infrastructure also plays a great role. So, in this module, we are going to have a glimpse on all of these aspects. The primary objective of digital library is to meet the information needs of its users. Now, digital libraries have to be more and more responsive by maximizing the innovative impact of advancement in information and communication technology. In fact, this digital library movement has taken all the advantages and benefits from all the recent advancement, and in fact previous advancement in information and communication technology. Now, see, to establish the digital library, one has to establish the infrastructure for managing, indexing and disseminating multimedia content. Please keep in mind that when we talk about digital library, it's not textual information. We will be dealing with all kind of information, that is text, graphics, images, maps, audio, video and any other format. This may include computer softwares also. And to host this and in fact manage this and disseminate this, a scalable technical infrastructure needs to be carefully planned to meet the functional requirement of digital library. Hardware, server allocations, databases, distribution approaches, network infrastructure and bandwidth considerations are key in establishing the digital library as a resource that can be used by everyone, that is teachers, students, researchers, faculties as well as general public, whomsoever is interested. Now, let's see the network and computing infrastructure which may be required for implementing digital library. In fact, establishing a digital library requires a great deal of computer, and when I say computer, it includes both software and hardware along with network infrastructural component. That also includes routers, switches, cable and other things, firewalls and all. When we need to integrate all the components to form a digital library, please keep in mind that there is no single solution is available. There is no turnkey based solution is available that is monolithic in nature. And if you think that, okay, I will procure this hardware and software for market, and when you think that when I will procure this hardware and software from the market and establish digital library, then you are wrong. You have to procure each component individually and then integrate them to give a shape of digital library. Digital libraries are collection of disparate systems and resources connected through a network and integrated within one interface, and currently which is web interface. If you want to integrate various components which are dispersed in nature, you have to use open architecture, standard and protocol, and that will make it possible that pieces of required infrastructure, be it hardware, software or accessories, are gathered from different vendors and integrated to construct a working environment. While some of the components are required for establishing digital library would be internal to institution, but several others would be distributed across the internet, owned and controlled by a large number of independent players. The task of building digital library, therefore, requires a great deal of integration of various components. A digital library implementation requires an enterprise level technology solution that is scalable in both size and functionality with built-in reliability, availability and serviceability, that is called RAS features. The storage capacity of digital library should be scalable to accommodate its ever-growing collection without requiring a redesign and re-engineering of system design. See, in life of digital library, there are various phases, and so initially you might be thinking of, okay, I will create a digital library for images also, and then after a certain time you may get a mandate. Now instead of only images, you have to also take care of videos. Now as soon as you induce videos as part of your digital library, your storage requirement is going to shoot. Now you have to choose an architecture in such a way that at any given point of time, any additional storage requirement can be adapted and can be implemented without using much technical changes. It should be like plug and play kind of model. Currently, the servers from multiple vendors are being used by several digital library implementations for its scalability and RAS features. This servers also offers high availability features such as full hardware redundancy, fault isolated dynamic system domains, concurrent maintenance and clustering support, along with offerings for modular storage capacity that can be added incrementally. See, when we say fault tolerant system, basically it becomes responsibility of the digital library creator that his services should be available all the time, that is 24/7 cross 365. So there should be no scope or no chances that your hardware or network or software should fail, and this can be achieved by putting in appropriate redundant system in your digital library. So if one gets failed, the other can take over. A typical digital library in distributed client server environment consists of hardware and software components at server side as well as at client side. Clients are machines that are used for accessing digital library by users, while the server hosts the database, digital object, browse and search interface to facilitate its access. Now let's have a look on server side hardware components. Basically, servers are heart of a digital library. Servers for digital library implementation needs to be computationally powerful so that users' query can be responded within no time. Servers should have adequate main memory, that is RAM, to handle the expected work. Servers should have large amount of secure disk storage for the databases and digital objects. Servers should have adequate network bandwidth to meet the communication requirements. And the architecture should be planned in a way that there should be no network choke-ups. A digital library may need a number of specialized servers for different tasks so as to distribute the workload on different servers. This task may be one or more servers to store digital objects and other for multimedia objects. There is also a requirement of an index server that maintains the indices and support searching of data stored in distributed system. It is also required to have a right management system to take care of unauthorized usage and intellectual property right issues. For a smaller library, many distinct activities can be performed on a single server. So basically, key idea is for smaller library, you can consolidate number of services to the single server and you can save in terms of resources. But in fact, on other side, you will be compromising on performance issue. That's why I'm repeatedly saying it should be for smaller library. Larger library needs different architecture and different approaches. It is also important that the server is scalable so that additional storage, processing power, or networking capabilities can be added whenever required. Other components which are on server side are input devices. When you are going to create image-based digital library, implementation requires input devices like scanners, digital cameras, video cameras, and touchscreen systems. Scanners are available in all sizes and shapes. Flatbed scanners or digital cameras mounted on a book cradle are more suitable for libraries. This also depends on how much collection which you have and what are the number of objects that you are going to scan. Details on such input devices are available in modules on digitization as well as in the modules under the paper ICT applications in libraries. The storage devices. A digital library would require one or more server to store raw data, that is images, text, videos, and other things. Indices of a metadata also, so that to retrieve information from the digital libraries in desired fashion. Digital library collections that are too large to store entirely on a disk can use hierarchical storage mechanisms, that is called HSM. In HSM, most frequently used data is kept on a fast disk, whereas the less frequently used data is kept in a near line, such as an automated robotic tape library. So basically the principle is locality of reference. The most frequent used data will be near, so it can be fed speedily, whereas less frequently used data will be behind. And a good HSM can automatically manage and migrate the data from tape to disk and vice versa as required. The intelligent storage area networks, that are SAN, and network attached storage, NAS, are now available in which the physical storage devices are intelligently controlled and made available from a number of servers. In storage devices, redundancy is also another important aspect for the consideration. Again, as I told, see, if you have stored all of your data in a single hard disk, or maybe say 5, 4, 10 hard disks, and few of them fails, your data will be of no use. So you have to plan an architecture that your storage is always redundant and can be mirrored on different hard disks. So in case of catastrophic event or in case of failure, the data can be easily retrieved with minimal effort. And in fact, it would be your job keep this data current and updated. The effective storage management thus means providing for redundant copies of archived objects to ensure availability of documents in case of loss. A number of redundant array of inexpensive disks, that is called RAID. These RAID models are now available for greater security and performance. The RAID technology distributes the data across number of disks in a way that even if one or more disks fail, the system would still function while the failed component is replaced. Digital archives may also choose to make backup of copies on their own or to make arrangement for the other side to serve as a backup. Although the hard disk that may be either fixed or removable, the hard disk solutions are increasingly available at an affordable cost. Optical storage devices including CD-ROM, DVD-ROM, Blu-ray or optomagnetic devices in standalone or network mode are attractive alternate for long-term storage of digital information. Optical drives record information by writing the data onto the disk with a laser beam. The media offers enormous storage capabilities. So in short, your architecture should be planned in a way that you will have always a redundant storage as well as the offline storage in magnetic or optomagnetical material. Now let's see communication devices. Setting up a digital library requires network and communication equipment like communication switches, routers, hubs, repeaters, modems, and other items required in local area network to connect to the internet. This hardware and software items are required for setting up any network and are not specific to digital library. Friends, let's talk about server-side software components. To handle a digital library and its diverse resources, the hardware needs to be backed by a robust software infrastructure as well as number of components. See, keep in mind that any single software is not going to serve the purpose of digital library. You need a bunch of software that should interact in between. Now, the first and foremost requirement is the image capturing software. Nowadays, most of the scanners as well as digital camera comes with inbuilt image capturing software. Now, whenever you capture any image, the image is getting stored as a bitmap, right? And the text or image or a picture, everything is bitmap. And the problem with this is, like, if you want to search any text within the image, it is not possible to directly search the image. If you want to make the text inside the image searchable, you need to use an OCR software. For image capturing, normally people use Adobe's Photoshop or the open source variant, that is GIMP, that is General Image Manipulating Program, and that is freely available and it can be installed on any of the platform. Whereas for OCR, the popular is the ABIS, as well as there are also several open source variants are available. So what normally this OCR thing does is it scans your bitmapped image, it tries to extract the text from that image and correct it as per the database available in the OCR software, and then it creates an index so that you can search within the image. Now let's talk about the software required for operating digital library. To operate a digital library, first of all we will require an operating system. Most popularly, people uses Unix or its variant Linux because it is open source, no cost is involved, and you can get help from anywhere. Moreover, you need to run a web service on your server. So if you have Linux server, you can use Apache's HTTPD or Nginx or even Tomcat if you have a Java application, or in case of Windows, you can use uh, Microsoft's Internet Information Server. Moreover, to host your database, because database is always required on server to store the data in structured format and to make it searchable. This can be metadata about your multimedia document as well as the bibliographic information of your digital records. So one can use the Oracle, Microsoft SQL, these are the paid, or one can go for MySQL, PostgreSQL, which are freely available in open source. Moreover, if you have very large databases, one can always go for big data, that is MongoDB or NoSQL. These things are like presently evolving, and number of web application has been deployed on this particular platforms. Moreover, you need to have a search engine which can search across your resources. It should be able to search in your database, as well as it should be able to search in your multimedia contents. So you need to have a search engine which is specific to your requirement. Apart from search engine, you may need an authentication mechanism to protect the digital right of the document. This can be either solved by LDAP server or Intertrust SDK or Microsoft Active Directory. So in short, when we talk about server side software, it is not a single software. It doesn't come as a packaged version. You have to build your server in bits and pieces, that is a web server, a database server, and search and index interface, as well as the search engine itself. The server side software components also includes digital library software. A number of digital libraries are being constructed at present to utilize it. A number of digital libraries are being constructed at present utilizing a mixture of information retrieval, media management, and web server packages. Some of the important softwares used in setting up digital libraries are DSpace, Greenstone Digital Library, GNU Eprints, the Content DM from OCLC, Fedora, etc. Let's see feature of each one by one. The DSpace, which is available at www.dspace.com. www.dspace.org. Initially, the DSpace was developed in partnership with Hewlett-Packard and MIT, that is Massachusetts Institute of Technology, and at present DSpace is being maintained by the DuraSpace Foundation. The latest stable version is 5.2 and is available for download at the URL given on your screen. This DSpace captures, stores, indexes, preserves, and redistributes the intellectual output of an institution's research faculty in digital format. In fact, when we say intellectual output, it consists the papers written by faculty, there may be some good audio lectures, there may be some instructional videos, there may be anything. So DSpace basically captures anything. The DSpace accepts all form of digital material including text, image, video and audio files. The possible contents in DSpace includes articles and preprints, technical reports, working papers, conference papers, e-thesis, datasets. The dataset may be statistical, geospatial or from MATLAB or SPSS packages, anything. Images. These images may be normal pictures or scientific images or graphs, audio files, video files, learning objects and reformatted digital library collection. Moreover, this DSpace has been developed in a community mode. So whenever a user faces a problem, he can just port it. Whenever a user faces the problem, he can just put it on the respective forum and the fellow contributors or fellow users will always try to help in various difficulty levels. The another open source software is Greenstone Digital Library Package, that is GSDL. That is a suite of software which has the ability to serve digital library collection as well as to build new collections. It provides a new way of organizing information and publishing it on internet or a CD or DVD-ROM. This has been produced by New Zealand Library Project at University of Waikato and distributed in cooperation with UNESCO and the Human Rights Library Project. This is open source software and is available from the URL which has been shown to the screen. This software is also available under GNU General Public License. GNU Eprints is also another open source digital library software package designed primarily to create institutional repository. The default configuration creates a research paper archive. It was developed at Electronics and Computer Science Department of University of Southampton. GNU Eprints is freely distributable and subject to GNU General Public License. The another one is the Content DM from OCLC. It is a multimedia software suite that provides easy loading, management and access to media archives in a library. It also provides tools to assist with every phase of collection development. Content DM can handle databases with millions of objects. Fedora, that is Flexible Extensible Digital Object Repository Architecture and popularly known as Fedora Repository System. It is again an open source digital object repository system developed jointly by University of Virginia Library and Cornell University and now being maintained by DuraSpace Foundation. The Fedora project is devoted to the goal of providing open source repository software that can serve as foundation of many types of information management systems. The software demonstrates how distributed digital information management can be deployed using web-based technologies including XML and web services. Now let's have a glimpse on client-side hardware and software components. Clients are machines that reside on users' desk. Planners of digital library need to prescribe minimum level of hardware and software that a user would require so as to achieve efficient and effective interaction with the digital library. Most digital libraries require an internet-enabled multimedia PC or a tablet equipped with an internet browser like Internet Explorer, Mozilla Firefox, or Google Chrome as their clients. The client-side PCs may also require the software packages which are being shown on your screen to download format-specific deliverables from a digital libraries. That may be internet browsers like Google Chrome, Internet Explorer, or Mozilla Firefox that can be downloaded from the URLs which are being shown to your screen. Again, see, you also need to take care that your browsers are loaded with appropriate plugins. Like suppose there may be some flash animations or flash videos, you may require a Micromedia Flash plugin or HTML5 player to see the video you may require Micromedia Flash plugin or HTML5 plugin to see the video content. So only browser is not enough. Sometimes you also may need to install the plugins. Some deliverable also requires several JavaScripts and cookies to be enabled. So your browser should be configured for the same. For PDF files, the most popular is Adobe Acrobat Reader that can be downloaded from Adobe site. For playing audio and video files, one can always download the Real Player or VLC player or any other player which is compatible with your file format. You may also need WSFTP, which is a popular FTP client. However, nowadays most of the browser also support FTP interface. For displaying and printing Word, PowerPoint, OpenOffice or Access documents, you may require to install Microsoft Office or OpenOffice to your client. For reading TIFF images, you may require TIFF Viewer. For image manipulation and editing, GIMP, that is the GNU Image Manipulation Program, can be downloaded from the gim.org. For video editing, Adobe Premiere is available, which is paid one. One can also scout for open source video editing software. Now let us have a look how cloud computing can play a role for creation of digital libraries. When we say cloud computing, it can be understood as a way to use off-site computer processing power to replace content creation and servers that were traditionally hosted on-site. Cloud computing allows content creation to be made when data and software applications reside on and are drawn from the network rather than locally on any workstation. The cloud computing can be advantageous and it will increase the ability of a library to try out new software without having to buy the hardware, as well as being able to scale the computing power to meet the demand of users. A library can increase quantum of cloud computing they require by contacting their vendors instead of physically acquiring new hardware to meet the increased demands. The general advantages of having digital library on cloud are compliant facilities and processes, cost effectiveness. See, it is always cheaper to subscribe computing rather than investing in a server and maintaining it in terms of air conditioning, furniture requirement as well as the electricity. So cloud is always cost effective. It gives you enterprise grade services and management. It gives you faster provisioning of systems and applications. It is flexible and innovative. It is flexible and resilient in case of disaster recovery. It is very highly secured infrastructure. It reduces hardware as well as maintenance cost because you don't own anything. You will have round the clock access. There is very simplicity of integration, and the cloud computing models are with simplified cost and consumption models. So you can take software as a services, you can take infrastructure as a services, or if you wish you can take platform as a services. It all according to your requirement. So friends, in this chapter we have seen the server side technology, the client side technology as well as the cloud technology, as well as we have seen the hardware as well as software aspects of all the three. And by looking at this, one can easily guess that these technologies are basically built around the prevailing internet technology as well as the web technology. And one can easily see that the basic principle of this technology is client server architecture. There may be 2 tier, 3 tier or n-tier, and you already know that the web technology is also built around client server architecture. Now the line is, or the key line is, once we try to implement this infrastructure, one have to be very careful. While choosing this technical infrastructure, one has to be very careful in choosing the hardware as well as the software. The standard should be open, the protocol should be matching, as well as there should be equilibrium between the economy as well as functionality. I hope this has increased your knowledge about technical infrastructure of digital library. Thank you very much.